When you dissolve any salt in the water, you add some salt in the water, the salt will dissociate into its ions into the cation and the anion. Now you can say you have A positive aqueous and the B negative aqueous. So when you add it, all of the salt will dissolve. But if you keep on adding the salt in the water, you will see a point will reach when the solution becomes saturated, means that you cannot add any more salt in it. The salt, all the salt that you're going to add after that, after the solution has attained the saturation, all the salt will precipitate at the bottom. It will not dissociate into ions. Now the solution is said to be in a saturation, right? So we have a saturated solution. So that means when we have a saturated solution in the water, in the beaker, you will find dissociated ions, right, and the undissociated salt also, right? So you will have an equilibrium there. So there will be an equilibrium between the dissociated and the undissociated the ions, right? Okay, the salt. So we have A positive aqueous and the B negative aqueous here. So now at equilibrium we can apply the law of chemical equilibrium here, and we can say the K will be equal to the concentration of the cation times the concentration of the anion divided by the concentration of the salt. Okay, and we can rearrange the same equation, like you can say the K into the concentration of the salt, and it will be equal to concentration of cation into the concentration of the anion. Now since the solution is saturated and the concentration of the solid salt here will remain almost constant, so I can write down another constant here, K into this one. Rather than this, I can say the KSP, which is called as actually the solubility product. That will be equal to the concentration of cation and the anion. Now since we have a saturated solution, the concentration of the ions that are present in the water is what you call as a solubility product. So solubility product of the A positive B negative ion will be basically the concentration of the cation into the concentration of the anion when the solution is saturated. So suppose we have a salt like the silver chloride, which is a sparingly soluble salt, dissociates to a very small extent in the water. When you add this silver chloride in the water, so you will see some of the salt will remain there dissociated. Very small ions will be actually there in the aqueous solution, right? And most of the salt will remain undissociated because this is a sparingly soluble salt. So you can write down it like this: Ag positive and the Cl negative aqueous. And you can write down here, since it is in a saturated solution, this is a saturated solution here, we can write down the solubility product of the silver chloride will be the concentration of the silver ion times the concentration of the chloride ion, okay, in the water. Now when the solution has not, suppose, attained the equilibrium, when the solution is unsaturated, definitely the concentration of these silver ion, of this cation and the anion, okay, or you can say here for this particular salt, when you have a very little amount of the salt in it, when the solution is not saturated, you can say the concentration of ions of these ions will be less than the solubility product. Okay, that will be less than the solubility product. When the solution is not saturated, there will be less amount of the salt, less number of the ions will be there. Correct. So now we use another term which is called as an ionic product. Okay, we use an ionic product here. So ionic product is you can say this has a much broader, this is a broader term because we use it for all types of salts, whether it is saturated or whether it is unsaturated. So ionic product is basically the concentration of the cation, okay, into the concentration of the anion, the same that we write here, but whether the solution is saturated or unsaturated, right? The ionic product is the concentration of the ions, the cation into the anion, when it is saturated or unsaturated or supersaturated. At any point of a time, whenever you want to find the concentration of those ions, okay, that is what you call as an ionic product. Okay, ionic product, you can say, is the concentration of the cations and the anions at any point of the time, whether it is saturated or the it is unsaturated, or even if it is supersaturated, right? So concentration of the cation into the the anion is what you call as an ionic product. And remember, when the ionic product is equal to the solubility product, right? When the ionic product here is equal to the solubility product, what does it mean? It means that the concentration of the cation into anion is exactly what it can have at the time of a saturation, when you have a saturated solution, correct? So when the ionic product is equal to the solubility product, that means the solution is saturated, right? So that means the saturated, the solution is saturated, and you cannot dissolve any more salt in it. No more salt can dissociate in it. Now when the ionic product is less than the solubility product, right? If it is less than the solubility product, so that means the solution contains less number of ions that it can hold in a saturated solution, right? So that means the solution is unsaturated, right? This is unsaturated, so means that you can dissolve some more salt can be dissolved in it, right? And if the ionic product, remember, if ionic product is more than the solubility product, right? If the concentration of those ions in the water is more than what actually it can hold, that means the solution is actually the supersaturated, right? Okay, this is the supersaturated. So that means what's going to happen? The precipitation will take place. Okay, the precipitation takes place here. So precipitation takes place only when the ionic product is more than the solubility product, when the concentration of those ions in the water, in the solution, is more than what it can hold. So definitely then what's going to happen? The solubility product, since it is the ionic product is more than solubility product, that means the precipitation will take place. Some of the salt will come out from the solution and it will precipitate at the bottom. Okay, now let's see how we can write down the solubility product of some of the salts. Suppose we have a barium sulfate. Okay, how can we write down the solubility product of this salt? And again, this salt, the barium sulfate, it dissociates into the barium 2 positive ion and the sulfate 2 negative ion. Okay, this is the sulfate 2 negative ion, so there will be an equilibrium like this. And you can write down the solubility product for here. It will be like the solubility product for the barium sulfate will be the concentration of barium ion into the concentration of the SO4 2 negative ion. Okay, and now what about the the Fe ferric hydroxide, FeOH 3 times ferric hydroxide. For this salt, if you look at the dissociation, it gives the one molecule of an iron 3 positive ion, and it gives you the 3 hydroxyl. Okay, the 3 hydroxyl. So the solubility product here can be written as the concentration of an iron into the concentration of the hydroxide ion power 3. Okay, power 3. So let's take another example of the magnesium hydroxide, MgOH. Okay, the magnesium hydroxide, MgOH twice. And again, that dissociates it like this. It produces the Mg2 positive ion and the hydroxyl ion here, 2 hydroxyl ions. Now you can write down the solubility product as the solubility product here for the magnesium hydroxide will be the Mg2 positive ion concentration into the concentration of hydroxide ion power 2. Right, this is how we write down the solubility product. Next we will do some questions on the solubility product. Hope you got it. Thanks for watching the video. Bye for now.